Alright, these next examples are still the same type of log equation as the ones that I just finished, but what we have to do in step 1 is a little bit different. If you remember in step 1, it referred to having a single log on one side by itself. And see here, this would not be considered a single log because you actually have two logs. So I've got to rewrite my left-hand side so it's just one log term or expression. And you're going to be able to do that by using some of the properties that we learned in the previous section. Since these two are separated with addition, what we learned is we can put these two terms together by multiplying our arguments. So I'll have log base 6 of x plus 5 times x is equal to 2. Okay, now that one step right there, you have it exactly in the form that you need it to be in now, so you're ready to go to step 2, which is to change it to exponential form. So I'll have 6 to the second power is equal to x plus 5 times x. Okay, you will want to distribute the x, and of course change this to 36, but before I write down the 36, look at what we have here. So when I distribute my x, I get x squared plus 5x. What I'm going to end up with right here is going to be a quadratic equation, and you're going to want to have that set equal to 0, so let's just go ahead and take care of that. Of course, we know that this is 36, so therefore you will end up subtracting it on the other side. Alright, so we'll see if this will factor. If it won't factor, then remember we've got our quadratic formula. But I do believe we can get this one to factor. Plus 9, x plus 9, and x minus 4. So I get x is equal to negative 9, and x is equal to positive 4. Alright, so let's go back and talk about checking again. Let's start with the negative 9. So if I were to take my negative 9 and substitute it here, negative 9 plus 5 gives me negative 4. Your argument cannot be 0 or negative. So checking it with this first argument immediately causes you to have to eliminate that choice. Okay, now the positive 4, of course 4 plus 5 is positive 9, so that checks there. Of course all you have here is just x, so if you put positive 4 here, then you will have a positive argument. So the positive 4 works, the negative 9 does not. Okay, next one. Alright, this one's similar to the one I just finished. Again, these two logs are separated by addition, but I can put these back together by multiplying my argument. So I can rewrite this as log base 3 of x minus 5 times x plus 3 is equal to 2. Okay, changing this over to exponential form, I would have 3 to the second power is equal to x minus 5 times x plus 3. Okay, you will want to FOIL this out, so we'll end up with x squared plus 3x minus 5x minus 15. And again, I'm going to go ahead, of course we know this is 9. I'm going to go ahead and bring it over here and subtract it because we do have a quadratic that we'll want to set equal to 0. Okay, so combining like terms. And now let's see, I do believe this one will factor for us. So we will need 6 and 4, and actually a negative 6 and a positive 4. So I have x equal positive 6 and x equal negative 4. Okay, so let's remember about checking. So if I start with my 6, 6 minus 5 is positive 1, so that's okay. 6 plus 3 is positive 9, so that's okay. But now negative 4 doesn't even, it actually checks in neither one of them, but you check it in the first one and you're going to get negative 9, so you immediately have to go ahead and throw that one out. Okay, Okay, next one. So we're still going to have to use our properties here like we have with the two previous problems, but this one uses a different property because I do have subtraction between these two log terms this time. So when I go to condense this, put those two back together, the subtraction tells me that I have to divide. So I'll have log base 4 of x plus 2 divided by x minus 1. Okay, so now that we have it as a single log, you're ready to change it to exponential form. So this would be 4 to the first power is equal to x plus 2 divided by x minus 1. Now to solve this one, you can just use cross multiplication. So 4 times the x minus 1. Of course, 1 times x plus 2 would just give us x plus 2. Alright, distribute your 4. Now, I don't have a quadratic equation this time like I have on a few of the previous problems. We just need to solve this one for x, get x on one side, numbers on the other. So I'm going to subtract my x, which will give me 3x, and then add the 4, which will give me 6. So my answer is x equal 2. And the 2 will check, because 2 plus 2 is positive 4, and 2 minus 1 is positive 1. So that one checks.